Ladies and gentlemen, please welcome to the stage Lisa Campbell.
Good morning. So I hope everybody had a great day one at AU yesterday, and now we're on to day two. Today what we're going to do is we're going to shift gears and we're going to focus on industries. And you're going to hear from speakers this morning that are going to talk to you about the opportunity of better in our industries. But one thing that is absolutely undeniable is the fact that technology is going to impact the workforce in the future. And I want to talk to you a little bit more about that. So the skills gap is a global challenge. We see employers that have millions of jobs open and they can't find the people with the skills to fill them. And yet we see millions of workers out there that can't find jobs. Now we know that technology is going to help fill some of those roles, but what we really need to focus on is how do we get people the skills that they need to work in collaboration with automation and with robots. Now, does that mean that robots are coming for our jobs? And by the way, I think that was a headline in Forbes magazine this week. No, we don't believe that automation is killing jobs. We do see that automation will eliminate some roles, but there's no shortage of work. So again, we need to focus on how do we give people the skills that they need to fill these jobs. Now, how big is that skills gap issue? Well, it turns out it's really big, and I'll walk you through that. So these are the estimates. We believe by the year 2050, we have to be building, on average, 13,000 buildings per day. It's about a 30% increase over what we do right now. And that's because there's going to be 7 billion people living in cities by the year 2050. And oh, by the way, 80% of firms say they actually cannot find the skills and the talent to fill those roles. And in manufacturing, the estimate right now is that there are 10 million manufacturing jobs that are not filled. Think about that. 10 million jobs that are not currently filled. And the estimate is that that is about $600 billion in revenue that manufacturing companies will lose over the next decade because these jobs are not filled. So we believe that automation creates opportunity. And we also believe that automation reduces waste, increases efficiency, and by doing that, it allows companies to do more. Now, one of the examples of more is, let's just say you're a civil engineering firm. Now, if you've been able to apply automation and reduce waste, in theory, you could take on more projects. So say you only do 1 or 2 projects a year. Maybe you can double that amount and take on 3 or 4 projects a year, which means you can hire more skilled workers to do those projects within, hopefully, the same budget envelope because you've been very pragmatic about how you've applied automation. But again, what we need to focus on is how do you find those people with those skills, because we just talked about all these jobs that are out there that we can't find people to fill. So one of the things that we did is we published a report with the Monitor Institute, which is a division of Deloitte. And what I want to share with you is what this study found about the challenges for this labor force that we're trying to find and skill. So what they found was 4 key insights. So the first insight is that we need to tie skills to more transferable skills. What does that mean? That means that you should learn things maybe more like analytics, creativity, curiosity, so that that can go from job to job. We're going to still need specialization, but we need skills that can move across industry jobs. The other thing that this study found was that we need to be able to upgrade the skills that workers have so that they can have more stability, because things are constantly changing. And so what you need to be able to do is constantly get these upgraded skills so you can stay stable in the jobs that you're in. Now, the third thing that they found was that we need to shorten the time from learning to actually bringing it into the work environment. And then last, the big thing that they found was that we need to address the systemic challenges that we have. So industry, academia, and government need to work better together to identify what skills are needed, how do you get people those skills so that we can then match those workers with these jobs that we are currently having unfilled. Now, what this has done, and it's led Autodesk to actually invest in a few initiatives, and I'd like to walk you through some of those initiatives. So the first one that I'll walk you through is tools, but we have initiatives in 3 areas: tools, training, and what I would call teaming. Now, the first one with respect to tools. Now, what you're looking at here is something that we just launched. This is the Fusion 360 command map, and it's a plugin. And one of the things that we can do with this is we can address that gap that we said, let's shorten the gap from learning to actual work. So what you're seeing here is every slice of this pie is a critical skill set, like modeling, sketching, CAM, simulation. Every dot is a project where you used that skill. And what's really interesting is as a user, as a designer, as an engineer, you can see how you've gone from basic skills to intermediate skills to advanced skills. Now, I want to show you what this command map looks like in action. So what you're seeing here is you have somebody who is designing a reciprocating handsaw. And what's really interesting is you'll watch as the user clicks the command map and can start to see where am I proficient on skills that we saw in that pie chart, and where am I not really good with a certain skill. And the command map will actually recommend to you skills that you need to get better at. It'll give you tips and techniques, and videos will be recommended. And in addition, you can actually benchmark yourself against other engineers in the industry to say, how am I doing with these proficiencies and these skill sets? So let's move on to training. And I said one of the other things that we're doing is we're investing in training, and we're working with an organization called World Skills. Now, this is an organization that's focused on skills and vocational training. And what's really exciting is what they do every year is they invest in a global competition. And we were really excited because yesterday we had one of those competitions here on Bim Modeling Skills. Now remember, what is their initiative all about? They want to give people the skills that are industry standard so that they can move into any industry and be able to bring these skills with them. And by the way, 45 skills are actually what they're testing against. 30 of those require Autodesk software. So we were actually very happy to host that here. And by the way, you can meet with some of these students that competed in this challenge at lunchtime in the EM Center. Now, the last thing that we invested in, we started to look at teaming, and we said, how could we work with organizations around teaming? And we have this initiative that we created that's called the Future of British Manufacturing. And what you can do with this initiative is any small or medium-sized enterprise can bring a business problem to us. And then we have what are called digital catalysts. So we have a digital catalyst program. And what happens is we try to map people that have these new technology skills to the business problem that a company has. And I'd like to share a specific example of where we had that. So there's a company called CP Cases. Now, CP Cases specializes in the safe transport of equipment, whether it's military equipment, musical equipment, or medical equipment. And as you can imagine, what they have to do in these cases is create foam inserts. These foam inserts are one-offs. They're custom because every piece of equipment is different. So their digital catalyst, who you see here, is Omar Hussein. And he's from the Imperial College. Now, he had fantastic Fusion 360 skills, and what we did is we matched him with CP Cases. And what he was able to do was some amazing things because their process was more 2D, and he was able to bring wonderful 3D skills. He actually took a process that was 180 minutes down to 15 minutes. CP Cases was so excited about this that they actually applied for another digital catalyst for this year. So for any of you that have a problem like this, go ahead to the website and you can find the Future of British Manufacturing, and you can also apply to get a digital catalyst that can help bring these digital skills into your company. So that's really where we've invested. We've invested in tools, we've invested in training, and we've invested in this teaming to really try to address what that Monitor Institute report talked to us about, where they said These are the 4 areas that we really need to sync up. So in tools, you could see what we were trying to do is shorten that curve between learning into the work environment. And with training, what we were trying to do is say, what are those future skills? All these jobs that remain open, what are the future skills and how do we get people those skills? And then with this teaming, we're trying to work better with government and industry to say, we have people with those skills, how do we match them to the jobs that you have? So in summary, we have a lot of demand for jobs out there, and we just don't have enough workers. Automation is absolutely going to address some of this, but we truly believe that more jobs are going to be created, and that what we really need to focus on is how do we give people the skills to work in collaboration with automation and robotics. And we believe if we achieve that, we can help people imagine, design, and make a better world. Thank you. So it is my pleasure to introduce our next speaker, Nicola Mangone, who's the VP of AEC Business Strategy and Marketing, and he's going to talk to you all about the wonderful creation of opportunity in the AEC industry.
Thank you, and good morning, everyone. You heard Lisa talk about the future of work and the importance of automation. So now we are going to show you what Autodesk is doing to help architects, engineers, contractors, and owners to leverage automation in their work every day. But before I start, I want to modestly share with you what Autodesk will be doing to help for the restoration of Notre Dame after the fire that happened 2 months ago. We will be helping the best experts in the world to work on this project. We just announced yesterday a partnership with the GMH and AGP. GMH is the Association of General Contractors working on historical monuments. And AGP is a long-time Autodesk customer specialized in scan-to-BIM for historical monuments. Together, we will be developing a detailed BIM model that will be shared with all of the professionals involved in the project. This is the roof before it burned. And our customer, AGP, has unique expertise in scan-to-BIM. It's the only company in the world that developed a complete scan of the cathedral, including the roof structure that no longer exists. In addition, they've been hired by the French government to do a complete scan post-fire. And today, they are working to compare the 2 data sets pre- and post-fire. We are excited to support this project by providing expertise and software. These type of monuments are important to renovate. It's important for the world today, and it's important for future generations. So let's talk about what that future will look like. Today, the population is growing, and the population is moving to cities. So we estimate that in the next 30 years, we'll have to build about 13,000 buildings on average a day, every single day. And we'll have to wrap around the Earth with road and rail network 30 times every year. These are global numbers. And many of you are working in emerging economies where a lot of this work will happen. But the numbers for Europe are also significant. Not only we need to build all of these new assets, we also need to maintain, improve, retrofit, and protect the current built environment. Today, the United Nations estimates that there's about £3 trillion at risk. 90% of the large cities are actually located in flooding areas, in coastal areas. And not to mention the collapsing and aging infrastructures, like this bridge you saw last year in Genoa, in Italy. So here in the UK, you are about 1 million people living in coastal areas subject to flooding. Also, our built environment impacts the planet. Today, buildings produce about 40% of global footprint. Us, living in cities, consume about 25% of fresh water. And the process of construction generates 30% of global waste. You all saw these numbers. Global construction productivity lags behind the total economy and also behind manufacturing. So we need to do better. Together, our challenge will be to increase productivity to respond to the demand that will come in the years to come. And we need to do it in a sustainable way. This is where automation comes into play. And today we are going to show you how Autodesk has been doing to bring more automation to design and construction. So let's start with design. One example of connected workflow is the work that we do with Unity. And connected workflows will improve automation. We announced a partnership with Unity in Las Vegas in November. And recently, they just announced the launch of a new native plugin for Revit. It's called Unity Reflect. So many of you have experienced the amazing technology that Unity develops for immersive experience that you can see here on the screen. But also, it takes time to create all of these experiences because you need to do coding, you need to map textures and materials, and it's a lot of work. What Unity Reflect does is with a click of a button in Revit, you can instantly experience Unity in this environment. So hours of work become seconds now. We've also been developing technology in our own design products. So 2 years ago, we introduced Dynamo for Revit. And Dynamo is visual programming that enables our users to automate tedious tasks, but also to program without knowing how to code. So I'm pleased to let you know that we released Dynamo for Civil 3D. This brings the full power of Dynamo for civil engineering workflows. Engineers can develop and share scripts to automate tasks such as generating complex geometry or also generating specific features like light poles and also signage. Dynamo workflows automate all of these tasks, and they are applicable for all of the civil engineering workflows such as rail, roads and highways, civil structures, or land development. The next level of automation is generative design. And historically, generative design has been hard to implement in AEC because it often requires specific expertise in terms of coding. Now, if you combine visual programming, like Dynamo, for instance, with an optimization engine that allows you to define specific criteria and explore many, many options, then it's going to change the way you design. And that's Refinery. Last year, we unveiled a public beta of Project Refinery. It's integrated in Revit, like Dynamo. And today, we are working to democratize generative design so that more of you can take advantage of it. Like this customer here, it's Land Security or Landsec based in the UK. Landsec wanted to see if generative design could help them in their feasibility process. They partner with Design Tech, an Autodesk partner, to create a proof of concept for generative design. And they worked together, and they could generate about 200 massing proposals for this specific project. They shortened the time for feasibility projects from 12 weeks to just 1 week. So now you know the kind of feasibility they will be doing with generative design. Today, there is a convergence or intersection of BIM plus IoT plus artificial intelligence, and it's going to create a new level of opportunities for automation. So let me explain. But first, let's look at some of the trends. So Gartner publishes every year the top 10 technology trends. And you can see things like autonomous vehicles or blockchain or things like that. But what was really interesting this year especially for us in AEC, is to see these two trends: smart spaces and digital twins. They are in the top 10. It's a big deal. And combined together, it really brings IoT and BIM together. So let's look at some cases. So let's talk about a smart space. So a smart space is an environment where human and technology interact. It's a space where we can capture insight about how people use the space. A smart space can be a smart building, a smart parking, a smart retail, also a smart city. IoT is creating an explosion of data that owners and operators want to leverage to better understand how people consume the space. And then, with that, they will want to optimize their assets to better serve their customers. It's a large and growing market in terms of software and technology. It's about a $7 billion market, and all of you should be interested to extend your services. So let's look at it. So here you can see a video that we took at AU Las Vegas. And computer vision and artificial intelligence makes it possible to dynamically anonymize and track the movement of attendees. By doing this, we could use the computer to see how people behave during the conference and how they responded to planned and unplanned activities. What we did here is create a digital twin of all of these attendees. The next level will be to present all of this information on a BIM model, which is really adding the digital twin of the physical space in the same environment. And here, it's a bridge. So in this example, you can see in real time the physical world with physical people and the physical bridge, but also its associated digital twin with digitized and anonymized people with a BIM model, right? So it's pretty amazing to be able to do that in real time. And then finally, what we can add to the scene is IoT sensor information. In this case, we instrumented the bridge with the sensors, with acceleration sensors. And as people walk, you can see these areas of the physical impact of the people in the bridge. So at the same time, we have people, the physical geometry, and also the physics of the space. In this case, it's acceleration. That's what we call a smart space. And here, it's a building example. And in this example, designers and operators can see how people will be able to move inside the building at different times of the day, and also depending on different conditions of temperature here. They will be able to compare as design and as perform models. Owners and operators will be able to optimize their assets in the short term. And designers will be able to use all of this information for future design. A few months ago, we announced a partnership with Capgemini. And together, we've been working to develop a digital twin platform to really extend BIM to operation. And this platform, strangely enough, is also called Reflect, just like Unity Reflect. It must be a trendy term these days. And the platform uses Autodesk Forge to automatically aggregate content from multiple sources, systems, and formats. So in this case, a facility manager can manage a complete portfolio of assets using GIS. And then, based on some notification or event, he or she will be able to access the BIM data from the GIS at the building level, but also at the component level. And in this case, it's an elevator failure. The operator will be able to understand what the problem is and also act on it. Every change or action taken will be updated back in the digital twin. This is a last example of smart space, and in this case, it's a smart city. We are making some investment in this area as well through our partnership with Esri. And to make a city smarter, you need real-time data. Our partnership with Esri brings together the power of GIS with BIM to help engineering teams stay connected in real time to improve operations of large or small infrastructure assets. Since our announcement of this partnership, we've released the Arcgis connector to Infraworks. It lets you access GIS information in your BIM workflows. With this data in a combined view, you can predict and prioritize where a city needs to adapt based on external factors, such as population growth, or also natural disasters. Whether it's a city, a bridge, or a building, BIM plus IoT plus AI is going to redefine the way owners can optimize their space, and also how designers will leverage data for future design. So in summary, by connecting workflows between products, by democratizing visual programming and generative design, and by leveraging data from IoT and BIM, we will bring automation to the design and operation space. But what about construction? So it's my pleasure to bring my colleague Vanessa Bertolini, and she's going to talk about automation in the construction side. Thank you.
So one of the ways that we can tap into automation for construction is by getting the computer to learn, act, and improve in the same way that humans do, autonomously. This is called machine learning, and it's done by feeding the computer data and information in the form of real-world interactions and observations. Earlier this year, we announced the preview release of Construction IQ. It's a machine learning-based capability in BIM 360, and it analyzes your quality and your safety data. Think of Construction IQ as your smart assistant that helps you achieve more predictable outcomes. Why is this important? Because your average construction site has hundreds of open issues, hundreds of RFIs, if not more, and numerous subcontractors on site at any given time. Construction IQ can look at that mountain of project data and help you make sense of it. It helps on-site quality engineers look at the quality risks they need to act on immediately and take action. It helps health and safety managers look at the health hazards on site so they can take action. And it helps construction executives look at the risks on their projects and take action. You heard Sam talk about Construction IQ yesterday. Royal BAM is using it. They've been using it for the past year, and it has helped them save 20% and spend 20% less time on their quality and safety issues and 25% more time on site dealing with high-risk items. With Construction IQ, their projects are more predictable and safer. Some of you may recognize this graph. This represents how data moves in a construction project and how, as it transfers during each phase, data is lost. That's because the AEC industry is so siloed. But by building a digital strategy for AEC, we can improve design and construction and automate the entire ecosystem. We're building this ecosystem today through acquisitions and integrations. We recently acquired 3 new construction technologies: Assemble Systems, PlanGrid, and Building Connected. Now alone, each of these technologies automates a different phase of the construction process. But together, and with our design portfolio, they can automate project delivery from end to end and bring design and construction closer together. Now, our acquisition of Assemble Systems allows construction professionals to query and connect BIM workflows to their project data on site. It does this by reorganizing the design model and helping turn it into a construction model. This results in the automation of quantity surveying, estimating, and scheduling. With a simple insight and BIM 360 together, customers have a holistic view of the project ecosystem, and they can actually have a single source of truth for their information. Our acquisition of PlanGrid was about bringing that data from design and pre-construction to the project site in the form of data sets. Now, I want you to imagine that you're a project engineer. Maybe some of you don't have to imagine too hard. You have an iPad on site with your 2D drawings. You click on it, and you automatically go into 3D. You have your BIM model right there, and you can see everything holistically that you need. This is here today. This is PlanGrid BIM, and it's one of many new integrations that we are bringing based on our acquisitions to you, and we're excited to bring more of these features in the future. Finally, there's Building Connected. Building Connected is a procurement platform with a robust network of construction professionals. It's over 800,000 strong. It helps connect GCs to qualified subcontractors. So we have plans to bring Building Connected to Europe, and customers in Europe are already using Assemble and PlanGrid. We've seen customers in the US have great success with all three of these products and BIM 360. Now, in order to access your data, you need it to scale. Automation is about scalability. And to scale data, you need it to be interoperable. That's what Forge is about. Forge's open APIs connect to your existing software and allow you to customize the workflows that you need. We have almost 100 integrations with Forge today. These integrations make your data actionable across the entire project lifecycle, and they grow the ecosystem of technology available to you. When data is actionable, you can work smarter and better. Before I go, I want to leave you with 3 things. Autodesk is actively working to develop, acquire, and integrate technology that can help you accelerate automation and improve productivity. Second, you heard Nicola talk about the convergence of BIM, AI, and IoT. This is really a game changer for AEC, and it's going to connect what we make and what we build to how people use those assets. And third, I want you to think about a project that you are working on today and how you might be able to automate an aspect of it. Could you look at space planning with generative design? Could you automate an aspect of your bidding process? How might you be able to embrace automation on your projects? As the examples I've shared show, with automation, we can achieve the opportunity of better design, better construction, and better productivity. Thank you. Now, it's my pleasure to introduce Dale Sinclair, and he is the Director of Technical Practice with AECOM. He's going to come out here, and he's going to share with you how they are embracing automation to converge design and construction and how it's helping them achieve better on their projects. Welcome, Dale.
Thank you, Vanessa, and good morning, everyone. AECOM is the largest AEC company in the world. We have 90,000 staff in over 150 countries. We design, build, and operate all sorts of assets, from roads and railways to communities and campuses. Our digital transformation team connect all our digital ideas across the world. And today, I'm delighted to show you some of the work of our team in London, where we're looking at design automation and the convergence of manufacturing and construction thinking to change and influence how we design our buildings to make buildings in the future. Now, BIM has been with us for a long time, and I know that many of you in this room have been using the concepts of Level 2 for a long time, such as the federated model, the common data environment, and the use of information for asset purposes. And also, tools such as BIM 360 and Navisworks, we use them to convert the challenges and the realities of our projects. However, what we're finding is that despite all these great developments, our clients are not seeing productivity improvements, and Nicola's already touched on this. So, what is it that we can do to define our tools better, to design faster, smarter, and better? Now, one of the reasons for limited productivity improvements is that we tend to plug BIM into very traditional ways of designing, based around heuristic thinking. So we're designing from our minds, from our heads, and of course, aligned to single project workflow. So if we are to look at how to design more effectively, we need to capture the iterative design process and use knowledge management techniques much better. Now, another challenge is that in addition, workflow and deliverables are remaining focused on 2D information. We certainly see a lot of models that are produced to create traditional 2D general arrangement information, with the detail drawn as standalone information in 2D or as callouts. Reviews are undertaken using flat, unintelligent information. VR is perceived as a gimmick rather than business as usual. So by persisting with the 2D paradigm and not fully committing to the 3D world, we are stifling innovation and productivity gains. We need to acknowledge that 2D is not out of date yet, but we must quickly move beyond this 600-year-old paradigm. In addition, with buildings producing 30% of the planet's waste, we also need to revolutionize how we make buildings. Buildings are the only things around us that are constructed. Everything else is manufactured, from planes, ships, phones, clothes, and cars. So surely buildings can be manufactured as well, in order to use less materials and generate less waste as part of circular economy principles. And of course, some people would say, no, this is not possible. Buildings are very large. They need to be anchored into their context, either structurally or to fit next to their historic neighbors. They need shaped to suit the characteristics of every site, and certainly every building has its own unique brief, and clients want buildings that mesh with their own brand. And of course, these are very valid arguments, but we would argue that buildings can be conceived in a way that can balance creativity with efficient and transformative ways of being made that are more sustainable. Now, before we look at this further, let's look at one of the projects that we're working on just now. So we're handing over a stadium in Cameroon just now. And of course, if I compare the stadium with the Colosseum in Rome, I might find more similarities than differences. Our stadium has been designed parametrically using the latest design tools and constructed at breakneck speed. But at the time, so was the Colosseum. And I think these projects act as a reminder that construction has evolved over thousands of years. And in the UK alone, members of the Construction Products Association sell £60 billion of products and materials for construction every single year. And so it's going to take more than one or two innovative projects to transform the momentum of the industry. Furthermore, the projects and materials that we use in construction are different to those that we use in manufacturing. Elements like the skirting board were developed to deal with the realities of construction tolerances. We use gypsum, we use clay, and we use timber. And of course, all these materials are developed for the human hand to place and construct on site. And the fixings are also different. So the screws and nails that we use in construction are very different to the more sophisticated fixings that we see in manufacturing. The Industrial Revolution did change things. It delivered a raft of new products, from the door handle to the WC to new systems such as the lift or air conditioning, using new materials such as aluminium. However, these new industrial processes made products geared back into the construction process. So if we're to shift to modern methods of construction, at scale, we need to forensically unpick these centuries of innovations and inventions and look at a new generation of products that are geared to manufacturing processes and robotic assembly. Now, volumetric construction is not new. People have been building hotels volumetrically for years. And in the UK, and I think actually in America as well, in New York, where this method is scaling into the residential sector, with a number of clients driving disruption by establishing their own factories. However, whilst this method is encouraging to see uptake, not every building can be transported on the back of a truck. And for larger buildings, from hangars to office buildings, we need hybrid approaches that balance traditional construction with new volumetric approaches and perhaps even new innovative techniques. Crucially, regardless of the modern methods of construction, productivity will not improve unless we transform design and procurement workflow as well. So, if BIM is not delivering the productivity improvements we need, what are the technologies that will change what we do? And of course, as AECOM, we're always scanning the horizon. We're looking at things from AI to drones, from 3D printing to VR, blockchain to the circular economy. Now, some of these technologies we're already using. Others we're experimenting with. But what we find is that we believe that more fundamental building blocks need to be put in place first. In fact, these pockets of passion, as we call them, actually risk diverting our attention from the topics that will drive change today. And to make the challenge more complex, our clients are being disrupted. If robotic surgery breaks the bond of the surgeon with the patient, how do we design the hospital of the future? If MOOCs change how we educate our pupils, how do we design a university campus? So as the momentum of the fourth industrial revolution builds, along with the increasing need to design zero carbon buildings that deliver better whole life outcomes, the process of designing is becoming more and more complex, underlining the need to find the tools that will simplify the design process. So, what are the solutions? How do we make the leaps that will transform our industry and allowing us to deliver faster information in smarter ways to deliver better outcomes? We started by looking at the decision-making process. And by way of example, we took a staircase, and we worked out that to design a staircase, we need to make 150 plus decisions before we got to the nuances of some of the concrete shutter layouts. However, once we've mapped these decisions, we find that we can automate a lot of these decisions, making many more than 150. We also found that we could decide who should make or contribute to each decision. We found that some clients want granular detail, other clients want minimal. And of course, some elements have to have options, others need to be configured. Others need discussion. So by using BIM to capture knowledge, we can deliver more focused, project-specific client decision-making, as well as reinvigorating the lead designer role. This is not about commoditizing design or standardizing design. It's about making the design process more focused and effective. With the decisions unpicked, we can start to work with suppliers and drive more and more detail into our models. We can hone the details, blending manufacturing more effectively with construction. For example, enabling balustrading to be assembled safer and in minutes, not hours. By using Inventor, we avoid the need for shop drawings, and with the focus fully on 3D, we can eliminate many of the common errors associated with 2D workflow and focus on the project-specific challenges beyond industry norms, automating construction and fabrication information. With AECOM's modular housing scheme, co-created with Rogers Sturck Harbor, we have developed workflow that allows us to create libraries of fabrication information that can be adapted as concept sketches are developed. And when we pull all of this together, we can produce our concept information in tandem with fabrication information. We're producing fabrication drawings at the same time as we're producing our planning applications, bringing clarity of detail and cost before the design is committed. As we roll out this way of working, our digital libraries become richer and richer, containing and capturing more information around carbon, cost, and value, aligned crucially to aesthetic decisions, allowing greater manufacturing thinking to be integrated into the completed project. We can work with the supply chain more effectively. Waste has been driven from the process. Quality improvements are clear for all to see around time, aesthetics, and cost. By converging Revit and Inventor, we have leveraged the benefits of Revit to face construction, and also Inventor's differentiators to face the language of the manufacturer. Bills of materials or BOMs replace bills of quantities or schedules of materials. Parts lists can be created as components are designed, developed, and added to our digital library, encouraging and facilitating reuse from one project to the next. And of course, once we more effectively converge manufacturing and construction workflow, we can examine who we collaborate with on projects. Here we see the new air traffic control tower at Istanbul's new airport nearing completion. AECOM co-created this with Pininfarina, product design and architecture converging. We need to transform the single project process to leverage our maturing digital library more effectively, shifting more and more workflow away from the single project process, looking at tools that will facilitate multiple project approaches. New workflow that better connects our interdisciplinary models with greater focus on the data that will drive better outcomes. With our content consistently structured and machine-readable, we can start to apply machine learning tools and better integrate 4 and 5D technologies. As this content and ecosystem matures, we realize that we need a new generation of product to face our transformed design process. For example, modular toilets have been available in the commercial office sector for some time. Yet, as an architect, I cannot go to a catalog and source one. Demand exists for a product that allows a pre-engineered carcass to be selected, configured for finishes and fittings with clarity around carbon and cost. Once the design is ordered, it is automated into production. The manufactured product of the future engaging with the design process of the future in previously unimaginable ways. The future of design in buildings will be incredibly exciting. We will design buildings faster, construction and design time reduced to facilitate earlier occupation. smarter, to decision-making, enabling whole-life thinking and co-creation with new partners, and better, information that goes beyond current norms. Let's make it happen. Thank you very much.
Ladies and gentlemen, please welcome to the stage Greg Fallon.
Wow, thank you, Dale, for that inspiring story about how AECOM is combining manufacturing technologies and techniques to revolutionize architecture and construction. I'm here to talk about how the manufacturing industry is being transformed by new technologies and new trends that are affecting manufacturers all over the world, and how we at Autodesk are working to help you, our customers, thrive in the digital transformation that's taking place. Earlier, you heard my colleague Nicola Mangan talking about macro trends that are shaping the future of making. He spoke about the need to do more with less and about the opportunity to do better. For manufacturing companies, the need for better is being driven by a number of factors. The products we design are becoming more complex. New materials, electronics, and sensors are in every new product or machine that we make today. Competition is increasing. Manufacturers need to have the ability to deliver new, improved functionality in an agile fashion. On top of all of this, customers are more demanding, expecting products to meet their personalized needs. This is great news for manufacturers facing these challenges, is that new means of production are showing great promise to help them do more with less. Advanced manufacturing methods and automation technologies are opening amazing new opportunities for manufacturers to increase productivity, to innovate faster, and offer flexibility to implement design changes without having to develop entirely new production processes. But these new technologies require a new way of working, new processes, and new tools to drive them. The problem is this: the tools that we use to do our jobs today, to design and manufacture products, are disconnected from one another, use different data formats, have completely different user experiences, and require users to manually translate, manually transfer, and often recreate data in different formats. It's a mess. The result on productivity is astounding. The average design engineer wastes 1/3 of her time on non-value-added tasks. Tasks like dealing with incompatible file formats, transcribing notes, re-recording comments in PLM systems. The opportunity for better for manufacturers is not only about making better products. It's about making processes better. It's about making work better. It's about making lives better. And the need for better is driving companies like Claudius Peters, who you heard about yesterday, to do things differently. For example, they're exploring new design and engineering workflows to improve product performance, like generatively designed, much lighter, clinker cooler trays that you saw yesterday. The design costs less to manufacture, is more efficient, and as a result, has less negative impact on the environment. But the opportunity for better at Claudius Peters extends beyond a single exercise in lightweighting. Claudius Peters is over 100 years old, and for most of their history, they've relied on traditional manual design and manufacturing techniques. They've come to the realization that in order to, in the words of their chief digital officer, avoid going extinct like a dinosaur, they need to evolve. So they've started a journey of digital transformation. Thomas Nagel, the chief digital officer at Claudius Peters, has put initiatives in place that he calls inspired excellence. The company has 4 goals for their digital transformation: to improve product quality, reduce lead times, reduce costs, and increase customer satisfaction. One of the key ways that Claudius Peters is realizing these opportunities is through Autodesk's collections. With the Product Design and Manufacturing collection from Autodesk, Claudius Peters has access to tools that help them streamline data, unite teams for better collaboration, and automate processes across disciplines, connecting BIM models with detailed mechanical component designs, similar to what Dale from AECOM just showed you. At the heart of the Design and Manufacturing collection is Inventor. This is Inventor on subscription. This is Inventor 2020. It's the fastest, most capable Inventor we have ever delivered. I recently saw a customer open a 2.7 million part assembly on his desktop. 2.7 million parts. Just a few years ago, that same model would have required special compute resources to open. But it's not just performance. We're investing in the entire experience. We're delivering the ability to model more complex parts, the ability to model and unfold complex sheet metal, streamline frame generator workflows, and much more. Like tolerance analysis. This is an example of how connecting manufacturing knowledge and data to the design process can help you make better decisions faster. In product design, the higher the tolerance, the more expensive the design is to manufacture. With a new tolerance analysis tool available in the collection, engineers now have the ability to optimally balance manufacturing quality and cost before a single part is cut. With these additions, Inventor 2020 is the best Inventor ever. Inventor is much more than a CAD system. Through the collection, we've built a number of workflows that are directly connected to Inventor. We've added simulation, we've added CAM, we've added nesting, and the collection includes Fusion 360, which contains our amazing generative design technology, the same technology that Claudius Peters used on their Clinker Cooler project. Fusion 360 is not only in the collection, it directly connects with Inventor. With the collection, customers are connected to the goodness of Inventor and the goodness of AutoCAD, the world's leading 2D design and documentation tool. Update your AutoCAD model, and your Inventor model updates. Update the Inventor model, and the AutoCAD model associated with it updates as well. Then there's Navisworks, reality capture, visualization with 3ds Max, and factory planning. And of course, everything is tied together with Vault to manage your data. The collection is about making connections. It's about connecting design to manufacturing. It's about connecting detailed mechanical models to BIM. Here's an example that shows how Inventor and Revit come together to connect detailed mechanical models of building components with the building model itself. This video is showing a balcony created in Revit, brought directly into Inventor, where it is edited and details needed for fabrication are added. Once this process is completed, the changes are passed from Inventor back to Revit with the appropriate amount of detail for the building model. In addition to integrating BIM and manufacturing workflows, we're making it easier to connect your engineering team with the rest of your business. The new Vault and Fusion Lifecycle connector makes it simple to manage your design data and engineering processes from one central location. And to extend the value of your data even further, we continue to advance the Forge Cloud Developer Platform. Customers like Moicon are using Forge technology to reimagine how we design and manage factories. Moicon is transforming the factory by offering continuous insight into operations, optimizing performance, and reducing downtime. Moicon is using Forge to create digital twins of factories and other facilities by connecting 3D models, facility management information, and IoT data together in dynamic 3D representations of factory floors. Forge, Vault, and Collections are connecting data, processes, and people. At Autodesk, our mission is to make you and your customers' lives better by connecting design to manufacturing. We're connecting data to processes and breaking down silos. Silos between people, silos between machines, silos between machines and people. It starts by putting data at the center of the process, establishing a unified product definition that connects everyone at every stage of the process, connecting industrial design, mechanical engineering, electronics, simulation, and manufacturing. With generative design, we're connecting designers and engineers and making it easy for them to quickly explore valid design options, confident that the results will be viable for production. Putting data at the center of the process makes it possible for us to connect design to production, to connect people and machines, to intelligently monitor production, connecting the top floor to the shop floor. Putting data at the center means it's possible to connect people inside your company to collaborators outside your company, at partners, suppliers, and customers. This is the convergence of manufacturing. This is the future of making. A critical element of the product design and manufacturing collection is Fusion 360. Fusion 360 is our cloud-based offering that is connecting and automating design and manufacturing workflows. Here to share some exciting developments about Fusion 360 is Marty Deans. Please welcome to the stage Marty Deans.
For decades, we've been using the term CAD, computer-aided design, to refer to any piece of software that allows a human to dictate a series of commands to a computer. But isn't it strange that we call it computer-aided design when the computer is basically just doing what we told it to? And what if you need to do more? What if you need to know more? Like the structural properties of that component, or is it manufacturable? Those are completely separate processes. So certainly, like you've heard yesterday and today, there's an opportunity for better. To help illustrate how Fusion 360 is delivering the opportunity of better, I'd like to introduce you to Will. They make a personal mobility vehicle to help those with physical impairments reclaim their love of the outdoors. One very important facet of their design is portability. So they've made their product modular with a goal to keep each piece less than 15 kilograms. Fusion 360 connects Will's entire product development process to the cloud, enabling new collaboration workflows so they can access their data anywhere at any time. It also combines all the tools they need into a single solution: industrial design, parametric modeling, rendering, electronics, documentation, manufacturing, and simulation. And now that we've converged design, simulation, and manufacturing into a single tool, we can work on automating those processes. Generative design in Fusion 360 leverages the compute power of the cloud to truly make the computer your assistant in the design process. And now we're really talking CAD. So let's take a look at what the generative process is like on this component from Will's front wheel assembly that they're ready to optimize. Sketch, Extrude, and all those other design tools we know and love, they're not gone. They're still there to give you precise control where you need it, to define areas to preserve, shown in green, and areas to avoid, shown in red. This lets you build the design space for generative to work within while maintaining the assembly tolerances you need to produce viable results. But that's not all we're considering. Generative design also explores multiple materials, performance goals like factor of safety and structural loads and constraints, and the manufacturing process. So if I'm exploring a couple different materials, a couple different manufacturing processes, and maybe even a few different load cases, you can quickly see I'm getting multiple hundreds, maybe, of results. This isn't topology optimization. This is not improving an existing design. These are new solutions that put the power to design a valid and manufacturable result in the hands of anyone. Now, over the last year or so, we've been delivering manufacturing constraints that have focused on advanced capabilities. And there have been customers like Claudius Peters, who you heard about from Sam and Greg, who've redesigned these generative results to fit their conventional manufacturing process with success. But now we're turning to automate that process. by delivering new traditional manufacturing constraints like die casting, 2-axis cutting, and this morning, I'm announcing the addition of 2.5-axis milling. Now let's break down why that's so exciting. So if we compare one human design to 2 generative results, under the same load conditions, the generative results exactly match our factory safety target of 3, while the human design is over-engineered, which makes it heavy. In fact, the 3-axis generative result is less than half the mass of the human design, while the 2.5-axis result is slightly over half. Significant savings in both cases. But the real difference is in the time to manufacture. The 2.5-axis generative result has a machine cycle time of around 35 minutes, while the human design is around an hour, and the 3-axis result is nearly 2 hours. And of course, it comes down to trade-offs. If I'm JPL and I really need those 18 grams of mass savings, I might go with the longer cycle time. If I'm entering large-scale production, I need to save every second I can. But with generative, you're not just getting 2 results, you're getting literally hundreds. And it comes down to those trade-offs. So we've armed you with the engineering data you need to make that decision, but we realize those aren't the only things that matter. So we're now starting to enrich that data with more data, starting with cost. So today, I'm excited to announce that A Priori is joining as our first manufacturing partner. A Priori is an industry leader in shape-based manufacturing simulation and cost insights. This is their solution, and it runs in the cloud, interrogating geometry and giving you feedback directly on the CAD model. Those 2 faces highlighted in red have an internal square corner. And for a milling process, that's going to require an additional setup, make me use a more complicated machine, or add an entirely separate process to achieve. A Priori lets me know that directly on the model, and lets me know that if I make a simple design change, like adding a fillet, it can significantly reduce the cost to manufacture this part. Now that's their solution, and you can work with them to gain that insight. We've partnered with them to embed that capability under the hood in generative design to make that cost insight available to you. Each result will have a cost range and an estimated median cost. We'll also allow you to visualize them on a scatter plot, so you can compare the cost the same way you compare that engineering data, empowering you to help make a practical and profitable decision. So we're democratizing design by adding new, accessible constraints to generative and enriching that data with cost in our partnership with A Priori. We're also continuing to develop Fusion 360's manufacturing tools. So this morning, I'm excited to announce the availability of the manufacturing extension. Now, Fusion already has the tools you need to go from design to make. The manufacturing extension expands the scope of Fusion 360's manufacturing tools for those who need a deeper level of functionality. It offers specialized tools to help you automate and optimize your manufacturing process from the individual toolpath level all the way through full manufacturing workflows. And we're delivering it in a modern way. There's no download, no serial number, and no high upfront cost to access the tools you need. So let's see what that looks like in Fusion 360. When you decide that you need access to the manufacturing extension, you turn it on directly within the interface. From the second you click OK, those tools are ready to go. Steep and Shallow, which some of you might recognize from PowerMill, is an optimized finishing toolpath that's capable of finishing full freeform components in a single strategy. Hole Recognition automatically detects hole profiles and applies customizable drilling templates. And if you've ever had to manually select every hole on a base plate, you know that's pretty powerful stuff. In-process inspection adds verification workflows to Fusion 360, allowing you to inspect freeform surfaces and geometric features so you can ship high-quality parts with limited human intervention. And finally, additive manufacturing is joining the toolset in Fusion 360. So you can build additive supports, generate additive toolpaths, and simulate them. But the real power here is they're coming alongside all the subtractive functionality already available, creating a fully hybrid manufacturing environment in Fusion 360. So today, I've showed you how we're making generative design practical with traditional manufacturing constraints to help you design better parts. How we're partnering with a priori to give you cost insights to help you make better decisions, and how we're continuing to deliver manufacturing tools you need when you need them so you can manufacture better products. All ways in which we're delivering the opportunity of better. So I know what you're thinking. How do I get access to Fusion 360? Well, if you're in the collection, if you're subscribed to the collection, you're already entitled. And if you're not, I want to try something new today, so bear with me. On the screen behind me, I have a QR code, and if you take out your phone camera and scan that QR code, it will take you to a website where you can enter your email, and we will send you a link so you can download a free trial of Fusion 360 today. Thank you. Oh.
Good job. All right, thank you. So I just want to wrap up today and just give you a little bit of a summary. But first, I just want to thank again Nicola for the great job he did, Vanessa, Dale, Greg, and Marty. Let's give them a final round of applause. All right, so just a quick recap. What did you hear? By the way, you've heard this over the last 2 days. Number one, you've heard that every single one of our industries is dealing with demand. We need more buildings, we need more products, we need more infrastructure. We've also heard that we are dealing with the reality of less, right? We have a shortage of workers. We're constrained with the amount of resources that we have in the world today to be able to deal with all of these demands that we have. So one of the things that we've talked about is the big way to be able to address this is through automation. And if we do that wisely, we can address these challenges. Now, one of the other things that we talked about doing was automation can actually help us address some issues, whether it's routine, whether it's dangerous work. But what's really important is that when you apply automation, you can actually transform the way that we do design and make and construct today. And we need to put people at the center of this process. And when we do that, you see things like construction IQ, and you also see things like what we talked about with Claudius Peters and the things that they can do and accomplish. So what I would leave you with is that we need to be very smart about how we apply automation, make sure that we're giving people the skills that they need so that they can work in collaboration, and with that we create this opportunity of better in all of our industries. So with that, we're going to wrap our morning main stage, but what I would like to invite everybody to do is go to the Future of Making showcase that we have across the hall and make sure to go visit that, and I hope that you have a great rest of AU. Thank you.